welcome Colin Richards.
All right, thank you. Okay, so in biology, there's this word called carcinization. It's a hard word, but it means this term of like convergent evolution, where animals are like becoming more like a crab. And it's like all these shrimp are slowly evolving into crabs because it's the superior animal in nature. And so in software, we have the same term, carcinization, where people rewrite existing software in Rust because it's the superior software. Even though no one asked them to rewrite the software in Rust, they decided they needed to rewrite it in Rust. So I'm here to talk, so I'm Colin, and I'm here to talk about my project, tmux-rs, which is my rewrite of tmux from C to Rust. So if you're not familiar with what tmux is, it stands for terminal multiplexer. And so what that means is basically it can split a terminal into multiple windows, or you can run it in the background. So I'll kind of show you that briefly here, because I'm actually running my presentation inside of a terminal. So you can like split the windows like that, and then run different commands from the command line. So that's kind of like what tmux is, and so that's an existing piece of software that's already written in C, and so my project was rewriting that from C to Rust. And so like, why did I decide to do this? And the short answer is just for fun. I didn't really have anything better to do. I mean, otherwise I would just be playing video games. So I think it's like a pretty good use of my time. So today, I'll talk a little bit more about actually why I chose this as a specific side project I was working on. And then kind of delve into the development process for how I accomplished this. Like, it's quite a lot of lines of code that I refactored, and some of the problems I encountered and like how I debugged them, and a lot of the like patterns in like C code and how I rewrote those in Rust. Is the font big enough? I can make it larger if it's a little bit too small. I'll resize as we go. Okay, so why did I decide to do this project? So sometime last year, in like the news feeds or whatever of programming, there was something called like DARPA's Tractor Initiative, which is a program they had. So Tractor stands for Translating All C to Rust. And so they had this program where they wanted to try and automate translating all this existing software that's written in C to Rust. And a lot of people were commenting on this, like, oh, you can't really do this effectively. And other people were mentioning that there's this existing piece of software that works called C to Rust. So I wanted to try that out. So I had this in the back of my mind as like a side project idea. And I always work on a lot of different side projects just for fun. I'm always programming on different things. So I kind of had in the back of my mind, okay, I want a good project that I can rewrite from C to Rust to try out this tool and see how good it is. And so I chose tmux because I use it every day, and it's a piece of software that I really enjoy using. And it's also not too big of a code base. So just like number of lines of code, it's 67,000 lines of code, but that's like if you include comments and empty lines, I think it's closer to like 80,000. But it's not so big that it would take me forever, but it is quite large. So I think it is an accomplishment to do this. And the code base is also well maintained. So it's quite readable code and understandable and so on. And so the other thing is there's actually an existing program that's very similar to tmux that's already written in Rust called Zellige. And I've tried it out before, but actually my own personal preference is tmux. So that's kind of why, you know, like some people might ask, oh, why don't you just use this other thing? And that's kind of, I just prefer tmux. So, okay, so why should you care about me rewriting this? And I think I'll have some interesting development approaches to share with you about how I approach this problem. The only other project I know of that has taken this approach for rewriting their code base in this way is Fish Shell. I don't know if you're familiar with that, but they kind of took a similar approach where they ported it piece by piece and slowly yeah, and then switched over to the new code base. But that's a little bit different because I'm kind of an outside entity. That was part of their own project that they decided to do that internally. And the other reason is more and more software nowadays is written in Rust. So I think it's a useful skill to have to be able to at least read and write some Rust so that in the future when more and more code is in Rust, you can contribute to those projects. All right. So these are some examples of some projects that, these are all, except for the Linux kernel, these are all projects that were completely rewritten to Rust, not like adding a little bit of Rust. And so, but the Linux kernel is one where they're slowly introducing pieces of Rust. And their stated reason for many of these projects is Rust hits a sweet spot of speed and memory safety and reliability. But that's kind of the stated reason. I think the real reason why many of these projects port is actually writing Rust is a lot of fun. And that's my own personal reason why I kind of took this project. And so like, why is it fun? I think there's two big reasons. The first one is it has a great type system. So that's like, once you use Rust and interact with the type system, I think it's difficult to go back to other languages that are not as strongly typed. So that's the first reason. And the other one is all the great tooling is built in. So languages like C and stuff like that, there's Clang format, there's a lot of existing tooling that exists, but it's a little bit tricky to set up properly, and it's not the default. Like every language ecosystem has its own different setup. So Rust, all of these great tools are kind of built in out of the box, so it's very easy to use. And one thing I'll add is the stated reason that a lot of projects switch to Rust is memory safety. And that doesn't really apply to my port of Rust, or of tmux to Rust, because the way I implemented it is completely unsafe. So that doesn't apply. So I guess, the real reason for me is just fun. Eventually, like in the future, I'll try and refactor everything to be in safe Rust, but I'm not there yet. All right. So I started out this process using that C to Rust tool, and it's a little bit difficult to set up. I think it's been improved a little bit. You have to use a specific nightly version of the compiler, but once you get it installed properly, you can use some tool. You just build the project like you normally would with like a C compiler. So tmux uses autoconf and make, and so you have this other program that intercepts make, and it's called bear, and so it intercepts all of the CC or GCC commands that are invoked when you run make, and it generates a file called compilecommands.json. And Clang and other IDE tools use this when you're modifying C files, so it knows how to do type information and stuff like that. And C to Rust knows how to read this file so that it can transpile the code, and it's aware of your project structure, because every C project can have a slightly different project structure, and you need to be explicit about how you tell it that. So what does the compiler output look like when you use this? So what type of code does it generate? And it's actually not so good. So this is an example of just some output, just a snippet of the compiler output, and it's pretty yucky. But that doesn't really give you a picture because you don't know what was input. So here's an example of just a function in the tmux code base. It's called color palette get, and it gets a color from the color palette. It's not too bad code. If you're not familiar with C, it probably looks very cryptic, but if you're a bit more familiar with C, it's not too bad. Now I want to focus on just a single line in this code. So this line, it's just what it's doing is it's doing some bit manipulation. So it's just a single operation, and then now let's look at the output, the generated output from C to Rust. And so actually, you can't even find that line of code unless I highlight it for you. So I've done that. So it's that line of code. So, and also one other thing, we need to zoom out. So I think that kind of demonstrates a couple of the problems with this C to Rust tool. So I have them highlighted here. Let me read. All right, so I think the first one and the most important one is you kind of lose information from these variable names. So it just so happened that color flag 256 was a macro, which is why we lost that information. It wasn't a variable. And so the way the C to Rust transpiler works is it has to expand those macros. So it lost that information. So I kind of see that as like one of the big like losses or like problems with C to Rust. And there's also all of these casts that are in the generated code, these like libc int casts. And the C to Rust transpiler is doing that because C has very odd rules for called integer promotion. So if you add two numbers in C, there's very odd rules that the arithmetic has to follow to avoid overflow. The details aren't important here, but basically it has to generate all of this like crap just so that you can like, so it can be like valid. When most of the time you actually don't want any of that in the Rust code. And then the other thing is it deduplicates all of the macros, so it expands all the macros, and you end up with like Rust code that's 3 times longer than the original C code and doesn't like retain any of the original meaning. So I started using C to Rust and I transpiled the whole code base from C to Rust, and I started translating the Rust code to like better Rust code that was more readable. And I realized after I translated like 2 files that actually it was slower to do this because I had 3 more times code and I kept looking at the C files to understand the original code. So I decided, okay, well, I'm looking at the C files anyways, I might as well just translate it directly from C to Rust and skip this tool. And that's not to say I don't think the C to Rust tool is not useful. Actually, I think it's a great tool because it showed me that this goal was like accomplishable. Like it generated code that could compile and run properly. So I knew that like I could achieve my goal like at the very beginning from day one that this was possible. Okay. So my kind of workflow after I decided to start manually porting the code. So first I used another tool called bindgen, which you run on the C headers and it generates Rust declarations so that from the Rust code you can call C functions. So this way I could slowly port some of the code without integrating everything. And so my process was picking a file, and I actually listed all the files out by length. I started with the smallest files, so I picked a file, and then I translated it file by file from C to Rust. And after I completed a single file, I modified the makefile and all the make configurations so that that C file was no longer included in the project and the Rust file was. And then I rinsed and repeated. And eventually I got to the point where the length of the C files were about 1,000 lines long each. And at that point, I couldn't translate it file by file because I would accidentally make translation errors and there would be bugs. So I changed my approach, and instead of doing it file by file, I did it function by function. So I would choose one function in a file and then translate that function, and in the C code I would comment out the function and implement, but leave the header. And so that would allow everything to compile and then it to call the Rust code. And so I continue doing that function by function. And so kind of like what the project looks like, you have, so at the top here we have like kind of the build files in the C project. So you have the make file, and tmux specifically. So every C project has a different build setup. So tmux uses autoconf, which is like some script that generates a make file. And so I was just modifying the generated make file or one of these files so that I could remove the LinkedIn C files as I was working on the project. And then I compile in my shared or my static library with Rust code. And what will happen is when I remove a function from the C code, I'll add it in the Rust library. And so when it calls that function, it will actually call the Rust code. Okay, so just zoom in a bit more. All right, so actually I want to look at the bugs first. I think that's the more interesting thing about this project. So I'm going to talk about the bugs that I encountered while working on the project, and then I'm going to talk about kind of like more like code structure and stuff like that. And yeah, so the first bug I encountered, or not the first bug, but the first one I'll tell you about, occurred after I translated a function that was so simple that it couldn't have the bug. So literally, I guess I haven't talked about some of the details. So a lot of this like cruft here, this unsafe extern C is just, the headers need to match properly. So the headers need to match, the signature needs to match the original C code so that everything calls properly. So I implemented this, and this function, all it does is access a field in the struct and returns, the field happens to be a pointer, so it returns that value. Now, after I translated this function, the program started crashing. And actually, this was the function, one of the first ones where I had like 1,000-line file, and before I switched doing it function by function, I was like file by file. So I translated like the whole file, and I like searching the whole file for like, and this function, which is like clearly not wrong, was what was causing the crash. So it's like pulling out my hair, like what is the problem? So, okay, there we go. So I ran it in a debugger, and the function returns, I ran it in a debugger, maybe with address sanitizer or something like that, and the error message is this: invalid read at address OX2764. So this should already look a little bit fishy to you, because this doesn't look like a valid address. This is too short to be a valid address. But so I looked into it more. I stepped inside of the function and printed that variable c.bar, and it was OX60302764, some value. And then I go up one level, and the value is OX2764. And I'm like, what? How in the world? Like, just returning from the function, the value has changed. And so maybe you'll have an idea what the issue is if I give you another hint. And so if I looked at the compilation warnings of the C code, because the compilation process was kind of janky at this point, I would have noticed this. And it says implicit declaration of function get address. And what this is, if you're not familiar with C, is in C, every function has an implicit function declaration. And that declaration is like returning an int and accepting any number of parameters. It's like a printf function where it can accept a variable number of arguments. And because the signature of the header didn't match, because it was the implicit declaration, didn't match the signature here, there's undefined behavior. And so what is that, or what's the undefined behavior? It's the return value of an int. An int is 4 bytes, but a pointer is 8 bytes. So it's truncating off the top 4 bytes of that address, which is why we see like, those values there. All right, the next kind of bug I encountered is basically the same exact thing. It's like, this function should not be causing a bug. So I kind of like realized after this issue that, okay, like there's this thing that's like, I don't know, this quote from like Sherlock Holmes or whatever. It's like, after you've eliminated the impossible, whatever remains is like the truth. But I think in programming, it's like, after the impossible occurs, it's UB, it's undefined behavior. Something like is happening that's like undefined. So, let's see, I switched. Okay, so for this, I stepped through it in a debugger in both the C code and the Rust code. And I noticed something odd. The address offset was different when it was dereferencing that pointer. And so what that actually was, I realized that the definition of client was slightly different in the C code versus the Rust code. And so that it causes this offset to be incorrect. So when I was accessing and writing to that foo value, it was actually corrupting the data and writing to Baz because these types didn't match up. And so this was quite difficult to catch. But it was as simple as changing the type in the struct, and then everything worked. Okay, so now I'm going to cover some C patterns in Rust. And so in C, you have pointers. And in Rust, you have references. And typically in safe Rust, you would want to use, or in regular Rust, you use references to act as like pointers, like they kind of are the equivalent. But when you start doing unsafe Rust, there's certain invariants in that Rust references must hold that are always true, but C pointers, it's not always true. So an example is a Rust pointer can never be null, or sorry, a Rust reference can never be null, but a C pointer can be null. And so Rust has another type called raw pointers, which don't have these invariants that you have to uphold. So in all of this code, because of the way I've ported it, I have to use these raw Rust references instead of the normal types of Rust references you would use in safe Rust code. So it kind of means that the code that I've written is quite unidiomatic and quite ugly, but it's kind of a side effect of what I have to do for how I've ported the code base. Okay, so there's a couple other interesting patterns I want to cover. So in the tmux code base, they use goto occasionally. So goto allows you to jump to an arbitrary place in the function. And the Rust code, in order to implement goto, I implement it using breaks. So the tmux code base, its use of goto is pretty much restricted to just forward jumps and backward jumps. And so you can emulate forward jumps in Rust using a labeled block, and you can emulate backward jumps in Rust using a labeled loop with just a continue statement. So these are like a couple ways that I emulated these features of C that exist that don't exist in Rust. And actually the C to Rust project, they implement it in a different way. So they have a whole algorithm that needs to handle all different cases. tmux is kind of restricted in how it uses goto, but there are a lot of ways you can use goto that couldn't be handled by these very simple ways that I used. So they implement an algorithm called relooper, which kind of completely makes the code quite different. So that snippet I showed at the very beginning was actually a snippet of the code generated from relooper, which completely transforms the code. All right. So there's one or two more things I want to kind of talk about. So one interesting pattern in the C code base in tmux that's used everywhere is they use intrusive data structures to represent two data structures, so red-black trees and linked lists. And so in a lot of C code bases, you'll use intrusive data structures. And so, well, let me explain what that is. So an intrusive data structure, basically, it's a data structure that requires support from the struct that it's holding. So that struct has a pointer into the data structure. So the data structure is intruding into the struct by inserting a pointer inside of that struct. And so typically in most code nowadays, you won't use these type of data structures because most programming languages have support for generics and stuff like that. So you don't actually need to use this pattern. But I implemented a trait which allowed me to make use of the existing layout, so I could match the layout of the C code exactly in the Rust code. And so in the C code, they used a lot of macros making use of these intrusive data structures. So they have this macro called RB for each to iterate over all of the elements in the red-black tree. And it needs to be a macro in C in order to implement it in a generic way. But in Rust, I've actually implemented it using a function which returns an iterator. So I can kind of do it in a more idiomatic Rust way. And in order to do that, I actually had to implement a trait, kind of an ugly trait on this type. And so I'm quite happy of this code, how nicely it matches the original C code, that you can it has the same structure. But the code that's required to support this is quite ugly. So I had to implement something that's this quite big piece of code to kind of enable that trait. And so that that RB for each function returns an iterator, and it creates an iterator that follows the, or that you can use in the Rust for loop. Okay, so the last part of the refactor, I've refactored all of the C files from C to Rust, but there's one file in the tmux codebase which is for parsing the configuration files, and it's a parser. So it's written in a language called Yak, which is a parser generator framework. And so I really struggled on how to implement this in Rust, because it's not even C to Rust, it's like this other language to Rust. But Yak looks a lot, so Yak generates C, and so it's kind of this set of like rules or action or patterns and actions. So it has a pattern, the grammar pattern, and then it performs some action. And I looked at a lot of different libraries in Rust that I could implement something similar. And eventually I tried like 2 or 3 different libraries. The one that I was able to successfully do it with is a crate called LALRPOP. And its structure of writing code is very similar to Yak. So it was definitely inspired by Yak. And so using this, I was able to kind of just straightforward port the code and able to successfully implement it. And so by doing this, I was able to completely rewrite, like finish the project and completely rewrite everything from C to Rust. And so kind of an overview a little bit on some of the development tools I use. So throughout most of this process, I used Vim. I didn't use a lot of like AI stuff. Towards the end, I did start using Cursor a little bit, but I actually stopped using it because I realized that it was kind of slow. Like I needed to read the code that was generated very closely because occasionally it would insert bugs. So I didn't trust it 100%. So the amount of time I would spend reading the code was the same amount of time it would have taken me to write it by hand because it's just mechanical translation. The only thing it really saved me was like sometimes my hands would hurt from like typing like 60,000 lines of code. Like, so it did help a little bit there. But so I finished the project and then I published it last month. And after I released it, I wrote up a blog post about this project, and it hit #1 on Hacker News, so I was very happy about that. And it got a lot of stars on GitHub and all this stuff. So I had my 15 minutes of fame or whatever. And yeah, and actually, so all those whatever likes, but I've had like a handful of contributors, and I'm like more happy about like the 2 people who are like actually using the code and contributing it than all the other stuff. So I'm very happy about that. And I've added like support for Mac and like very like weird architectures. So like you can run it, I can run it on my phone actually. So it's yeah, it's kind of cool. And so future goals are to use less unsafe and like all these other patterns that are in like unsafe code. I want to like get rid of that. And so my goal is like 100% safe Rust, but that will be a long process. Yeah, and so that's it. Any questions or yeah? Oh, you could, yeah.
I use this on my personal system, and when I do SSH, I use tmux
Yeah.
and or state.
Yeah.
So tmux is not exactly like slow; it's like pretty fast.
Yeah.
So the you only mentioned it like the URL is are basically related to Rust. Is like it gets like more speed sometimes, and like it gets more safe. It is not like major at this moment. So one question is that like do you plan to like I don't know like specific plans to make it somehow better than the actual tmux and make it like different feature-wise or something. And another question is this presentation made using present term.
Yeah, so that's that. Yeah, I switched to that slide here. So yeah, it is using present term. Yeah, I anticipated that question. But yeah, so the first so like features. I don't right now. I don't see extending it. I see. I want to be like feature compatible, implement all the same features. I even there's one interesting thing where like I kind of filed a bug on my own project because I noticed something that like maybe I can even. Well, I'm not actually. So right now. I gave this presentation. I'm actually running regular tmux, not tmux-rs, only because I haven't implemented SIXL support. So this image that's being displayed, I haven't implemented that feature yet, but that's my next feature that I will add. So yeah, so But yeah, so there's a handful of like things that I kind of consider bugs that are like, I'm not matching tmux exactly, like very minor things. I don't see any big features that tmux doesn't have that I would want to add, but maybe in the future I noticed like maybe toml support or some things like that that like would be super easy to add now that it's written in Rust, because I could just add a toml library. Could be a potential feature, but right now I don't really have any concrete plans. Yeah.
So, if so follow-up question. So it's like if it doesn't have like all that much differences from the like actual keyboards. So what do you think in terms of the like ecosystem perspective? Because usually it like things like more standards like XKCD 97.
Yeah.
So it's like same thing, but like in a different language, even more and more maintainability, more like split, and like the contributors are split, the users are split. So what do you think about like the effect in long term maintenance and the ecosystem?
I mean, I haven't really thought like extensively about that. I want to like, I would say I want to at least. So my plan is to track tmux features. So if tmux adds new features, I want to follow those features. And so I kind of would consider any like, at least at this point, I would consider any functionality that exists in tmux that doesn't exist, or like any functionality difference would be a bug in my project. So I would like want to maintain compatibility with it. But I don't. Yeah, I mean, yeah, I guess that's kind of like, I don't see like a project ecosystem split yet because it's like so small. Like literally it's like 2 people, probably like less than 10 people actually using this project right now. So yeah.
Have you communicated with Jing with any of the work?
I haven't yet. So I mean, it's like, I mean, who cares? Like, I mean, like, it's, I mean, I don't think my project is better. Like, the upstream code base is much better than mine right now. Like, even though mine is written in Rust, it's terrible, shitty Rust. Like, it's really bad code. So the other code is much more maintainable, much better. Like, tmux is also a part of like OpenBSD, maintained there, and like they're kind of a project that's like known for having like very, very good quality code. So my code right now, at least, is like significantly worse. Like I would not use my own project in like a production system, right? I only use it like on my own laptop and like something like I expect it to crash. So yeah. Yeah.
Could you elaborate more on how you refactor the inclusive data structure into Rust with the trace system?
I can flip back to that slide. I don't know if I have enough time to go over that completely, but if you're interested, I can talk with you about that later. Where was that slide? Yeah, the trait. One thing I didn't mention is because that intrusive data structure can be used, that like you can have. Because of how it's implemented, an intrusive data structure element can be in multiple collections at the same time, because you can have 2 different pointers that point to different lists, right? So that's why I actually had to implement this in using a trait with an extra generic field. It's like there, yeah. So I had to do like a little bit of a weird thing, because the trait system in Rust only allows you to have a single implementation of a trait for a given type. And so I had to do a little bit of a weird hack in order to allow this trait to be implemented twice for a given type, so it could be in 2 different collections at the same time.
There are no other questions. We would like to stop here for this session, and please.
And thank you all for coming. Okay. When I was in my college, I have suffered from the compiler class and those disgusting Yak compilers. Okay, so I can very understand the suffering from translation, those compiler things. And again, we have a warm applause for the tremendous translation from C to unsafe Rust. Thank you.